It on, it's on. Right, so 1 mole of CO2 and 3 moles of hydrogen were sealed into a container. After the mixture had reached equilibrium, it's saying at a pressure of 500 kilopascals, the yield of methanol was 0.86. They're giving you the equation, so what we see, we've got 1 mole of CO2 reacting with 3 moles of hydrogen through a reversible reaction to give us 1 mole of methanol and 1 mole of water. And it's asking us calculate a value for Kp, give your answer to an appropriate number of significant figures, and give the units of Kp. And it's quite a lot of marks, 7. So the first thing we're going to do is, this is the more complicated one, we need to build an ice table. So here I go with the ice table. So we need to have 3 rows after this as normal. And it's a similar trick to the KC, so what I will do is, if I put ice on here, just stands out a little bit. And then what we do, we put everything in there. Oh, actually we need another column. There we go, because there's 4. So we're going to have in here CO2, H2, methanol and steam, and then this stands for initial, I, C stands for change, and E stands for equilibrium. Right, now you put the data in the appropriate way, so we've got 1.0 moles of C2, and we've got initially 3.0 moles of hydrogen, and they were sealed in a container. That means at time equals 0, we have 0 moles each of the 2 products, the methanol and the steam. Then, after the mixture had reached equilibrium at that pressure 500, the yield of methanol was 0.86. So the methanol is here, so the yield was, which means 0.86 moles was produced. That means the change is a positive change, so it's plus 0.86, and because it's 1 to 1, this would also be a positive change, which means for steam you would also have 0.86 moles. This is at equilibrium, and that's simply because it's 1 to 1. Then to get the others, so the easy one is the CO2. Because it's 1 to 1, the change is a negative change, 0.86, because reactants are always used up to form the products, and this would be 3 times this value. So why? Because it's 3 to the ratio of 1. So I'll just do 0.86 times by 3. So 6 3s are 18, 8 3 24 plus 1 25, and then 3 times 0 0, there you go. So that would be 2.58, and that's a negative change. And now it's easy. So to find the moles of CO2 at equilibrium, all we do, we take away the 1 from that, because whatever that's reactive, whatever is left must be equilibrium. So that would be that would be 0.14 moles, and this would be 3 take away 2.58, which will be 0.42 moles. This is at equilibrium. Now we've done all the hard work now, so we find the total moles of the equilibrium mixture, because I need to get the, running through partial pressure. So the total moles of equilibrium, 0.14 for the CO2, plus 0.42 for the hydrogen, plus 0.86 times by 2, because there's 2 of those. And this gives me 0.14 plus 0.42 plus bracket 2 times 0.86 close bracket equals, that is 2.28 moles, yes? And now you set it up one time, so partial pressure PP of the CO2 would be equal, its moles at equilibrium 0.14 over 2.28, and we times that by 500. As you can see, that's the total pressure. Set up the other one, partial pressure of hydrogen, H2, is its moles at equilibrium 0.42 over the total moles of the gas mixture, 228 times 500. And then we've got the partial pressure of methanol, which is its moles at equilibrium 0.86 over 2.28 times 500, and the partial pressure of steam, the same 0.86 over 2.28 times 500. So you go into the Casio, 0.14 divided by 2.28 times 500, and we end up rounding to 1 dp 30.7, and that will be kPa. The hydrogen is 0.42 divided by 2.28 times 500. What's this? Oh, okay, 92.1 kilopascals. Then we have 0.86 divided by 2.28 times 500. And we have 188.6. And this will be the same. Now, the important thing whenever you're doing these calculations, you've got to add up, make sure, just double checking, this adds up to the total pressure 500, because otherwise in the exam you will lose a mark if that doesn't happen. So I'm just double checking that this adds up, and it does. Look guys, so it's absolutely 500 smack on. So I am running like a headless chicken, as you can clearly see, but it's worth it. So Kp, now we've got to write an expression for Kp, so it's the partial pressure of the methanol multiplied by the partial pressure of steam all over the partial pressure of CO2, again it's 1 mole, multiplied by the partial pressure of hydrogen. Now be careful, there's a 3 there, so that will be cubed. And now guys, we're just plugging the numbers in. The partial pressure of methanol, where is it? All the way down there. So it's 188.6. Steam is the same, 188.6 all over CO2 partial pressure, which is 30.7, times hydrogen, just be a little bit careful here, is 92.1, and you've got to cube this value because there's a 3. So on the Casio, we fraction button, 188.6 squared is quicker, then divided by 30.7 times bracket 92.1, close bracket, and then we cube that. Okay, and then, okay, there's the answer. So it's 1.48 times 10 to the minus 3. Now I've put it to 3 significant figures, and the reason for that, guys, is this value here of moles is 3 significant figures. That is 1 significant, that's 2, and that's 2. So it's better to quote it to the higher degree of accuracy. And lastly, the units, all we do, because it's kilopascals, on the top here I got kPa squared. At the bottom, the total power is 3 plus 1, which is 4, so it's kPa to the 4. They cancel out 1 over kPa squared, which is equal to kPa to the negative 2, so it's kPa to the minus 2. And that is the units, and I hope you've enjoyed that.